Okay, now we're going to get started on part 2 of our trig class. And hopefully you've had a chance after finishing the first one to get a little better understanding with the basic terminology and how we use it on those easier trig problems on the ACT. But now we're going to turn things in a little different direction. And I'll be showing you some of this through the screen that you're going to look at. But I want to start with one thing, and that is your first trig identity is sine squared plus cosine squared equals 1. All right, we could say sine squared x, cosine squared x, sine squared theta, cosine squared theta, whatever. This is trig identity number 1. Now the ACT will frequently present this in a little different way. Sometimes it'll be 1 minus cosine squared x equals sine squared x. All we've done is subtract the cosine squared over to this side. We can do the same thing by saying that 1 minus sine squared x equals cosine squared x. Now, here's the way the ACT uses this in some of their problems. They'll have one that'll say the square root of 1 minus cosine squared x divided by square root of 1 minus sine squared x is equal to what? Well, if you haven't done much in trig, this can be a little bit scary. You don't know what in the world this is meaning because you haven't seen a lot of this stuff before. But let's break it down as you should do in math, one step at a time. Remembering this, 1 minus cosine squared becomes sine squared. So we simply substitute, and we get that this is equal to square root of sine squared x over the square root of cosine squared x, because you see your 1 minus sine squared is the cosine squared. Well, now the square root of something squared is just the same thing back, so it's just equal to sine x divided by cosine x, which they want you to remember is tangent x, like we covered in the last video. So now you have tangent x. So the solution is fairly simple, but they really wanted you to know this trig identity right here. So this gives you just a brief example of how to use the sine squared plus cosine squared always equals 1. Now what I'm going to do is take you through the unit circle, and we're going to go through this step by step. I want you to really understand the unit circle and how our trig values play into it, because the unit circle and understanding these basic trig values is very important on the ACT. Okay, hopefully this is beginning to come together now. So what I want us to do now is work through some problems. We've gone through the unit circle. We understand a little better how those pieces of the puzzle fit together. Now it's time for some problems. We're going to work through a pretty good number of problems on this because the ACT can present this in so many different ways. And we're going to do just like we did in the Trig 1 video. You're going to have about 30 seconds to work on a problem, then I'm going to explain it. And you got 30 seconds on the next one, and I'll explain it. And we're just going to sort of work our way all the way through those problems like that. And hopefully by then, you're really going to understand it. And once again, like we tell you in other videos, if you feel like you didn't have enough time to work on it, just hit pause on the video, finish the problem, and then resume the video. You really need to get this. So with that, let's get started understanding our unit circle. We want to take a minute and get familiar with our unit circle and understand the terminology and orient what all's on this page. I've got a lot of information packed on here, and you'll see each of it has its own specific information that it shares, and it all ties together. But to start with, it's a busy spreadsheet, a little form, I know that. But let me just go ahead and show you a few things. First of all, we refer to these axes. If you look here, this is the y-axis, and this is the x-axis. Now what this is this shows us we have a 90-degree angle here, 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 and here. And what that does is it effectively divides our form into quadrants. Quadrant meaning 4. So this is quadrant 1, and this is quadrant 2, quadrant 3, and quadrant 4. All right, let me That's quadrant 4. Now, this is important because it tells us a little bit about the signs, the SIGNS of our functions. Okay, and we don't want to get that confused with the word sine, S-I-N-E, that we'll also be looking at. Now, one of the things to remember is in the first quadrant, we use this, or across this whole form, we use this expression, all students take calculus. ASTC. So if you picture it like this, what it's telling me, all students take calculus. This tells me in the first quadrant, all of my functions, sine, cosine, and tangent, are all positive. In the second quadrant, sine is positive, cosine is negative, tangent is negative. Third quadrant, tangent is positive, sine and cosine are negative. Cosine is positive in the fourth, sine and tangent are negative. This helps us when we're looking at particular problems. We're able to quickly pick out what the right answer is because we might be able to rule 3 answers out. If we know we're in the second quadrant, for instance, and they're asking us about the sine's positive. In many cases, you may just find 2 positive answers. For that tells you the other 3 are wrong. Now, we want to look. We call it the unit circle because the unit means it is a distance of 1 from the center of the circle. The radius is 1 in this one. So we would look at our circumference is equal to 2 pi times the radius, which is 1, which makes the circumference just 2 pi. And that's important, as we'll go over in the next step. What I want you to see from this is I'm going to tie together the waveform of the sine and cosine function. I'm going to tie together the values in the first quadrant and how to recognize the pattern for the rest of the quadrants for the video. And then we're going to look at the circle and how our 30, 60, 90, 45, 45, 90 triangles all work together for us. So we're going to start now by looking at the first quadrant and our 30, 60, 90 triangles. The first one we're going to look at is the 30-degree angle, and that's this first one that's in purple here. This angle is 30 degrees. Now, if you remember our 30, 60, 90 triangle, if you look at that, what you have is you go to your 30-degree angle, across from it is opposite, this is adjacent, this is hypotenuse. On the unit circle, when we look at the 30, 60, 90 triangle, what we have is my hypotenuse is a 1. Now, the relationship between the sides of a 30, 60, 90 triangle is that my short side across from the angle is half of the hypotenuse. So it is 1/2. The long leg, which is adjacent side, is going to be the square root of 3 times the short side. So that makes it the square root of 3 over 2. So if we label that and put the 1/2 here, and we put a 1 here, and we put a square root of 3 over 2 here, we are ready to look at what our sine and cosine tangent functions are. So for this first quadrant, what we have is sine is equal to the opposite over hypotenuse. Opposite is 1/2. 1/2 over 1 is equal to 1/2. My cosine is equal to the adjacent, which is this side. It is equal to the adjacent over 1. Again, it is the square root of 3 over 2. Now remember, back up at the top where we just covered earlier, sine squared theta plus cosine squared theta always equals 1. Well, we can test that. If you look at the 1/2 squared is 1/4. Square root of 3 over 2 squared is 3/4. 1/4 plus 3/4 is 1. Now my tangent down here is equal to my opposite, which is 1/2, over the square root of 3 over 2. Well, the 2's are going to cancel, and I just get 1 over the square root of 3, which becomes the square root of 3 over 3. So now we have our functions for the first quadrant looking at the 30, 60, 90 triangle. Now let's take a look at the 45-degree angle now. Okay, Now, as I look at the 45-degree angle, what we have is this line here. Now, if we remember our 45, 45, 90 triangles, what you would have is this is x, this is x, this is the square root of 2 times x. So in looking at that, if I know that my hypotenuse is 1, that means that 1 is equal to the square root of 2 times x. So now we divide both sides by the square root of 2. And of course we get to multiply by square root of 2 over the square root of 2. And we end up with the square root of 2 over 2 is equal to x. So this is the square root of 2 over 2. And so is this equal to the square root of 2 over 2. So if I label my triangle here, what I have is a 1, square root of 2 over 2, square root of 2 over 2. Which means that my sine is equal to square root of 2 over 2. And my cosine is equal to the square root of 2 over 2. And since those are equal, my tangent is going to equal 1. So that goes over the 45, 45, 90 triangle, and that's the way it's going to be. We'll see where to put those on the chart in just a minute. Now we're going to look at the 60-degree angle. So if we take our 60-degree one, that's this one right here that's brownish, and 60 degrees is just the 30, 60, 90 turned on its side. So this is 1, but now my long side becomes the square root of 3 over 2, and the short side stays 1/2. So what that tells me is that my sine of 60 degrees is now the square root of 3 over 2. It is the opposite over the hypotenuse. So square root of 3 over 2 over 1 is square root of 3 over 2. The cosine of 60 degrees is equal to 1/2. If you picture your tangent is the sine divided by the cosine, you can see that your 2's are going to cancel, and you're going to end up with the tangent of 60 degrees is equal to the square root of 3, period. Because it's the square root of 3 over 1, square root of 3 over 1 is just the square root of 3. So I wanted you to see how these functions go. Now we're going to take the next step and see how they tie in and where we put our numbers in the form down at the bottom. Now we're down at the bottom, and let's take a minute and write these numbers in. Notice this. The sine of 0 degrees is 0. The cosine of 0 degrees is 1. Tangent is 0 because it's 0 divided by 1. Okay, so if you look at this, sine squared plus cosine squared always equals 1. Well, 0 squared is 0 plus 1 squared is 1. 0 plus 1 is 1. That works. So now we go to the 30 degrees. 30 degrees, sine of 30 degrees, as we calculated, was 1/2. Our cosine was the square root of 3 over 2, and our tangent is the square root of 3 over 3. We go to the 45s, and it's the square root of 2 over 2, square root of 2 over 2, and 1 for tangent. 60 degrees, notice that these two numbers at 30 just swap places. The sine of 60 is the square root of 3 over 2. The cosine of 60 is 1/2, and it makes the tangent simply the square root of 3. Now we get to 90 degrees, and they swap places again. The sine of 90 degrees is 1. The cosine is 0. Tangent of 90 is undefined. We have no idea what that is because it's 1 divided by 0. So, wanted you to see this is where the numbers go. Now let's take just a minute and look at the pattern of how this goes. As you notice this, you'll see that we went on the 1 at 90 degrees. Now we start coming back down on sine, and it goes square root of 3 over 2, which is exactly what it was at 60. So if I add 30 degrees, it goes back down to the same number. When I go to 135, that's 45 degrees past the 90. It's the same as it was at 45. When I go to 150, it is 1/2, which is the same thing it was at 30. And when I go to 180, it is back to 0. So the pattern continues. Now after this, we'll take just a second and look at the next block. you'll see the sign goes negative. Like we said, it's negative in the third quadrant. Negative 1/2, now it is negative square root of 2 over 2, negative square root of 3 over 2, negative 1. Now it's bottomed out at negative 1 and it's starting to go back up. Negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and at 360 it is back to 0. Now you can go back, we'll back up and look at our cosine. The cosine function, as we see, went 1. Square root of 3 over 2, square root of 2 over 2, 1/2, and 0. So it's going down the whole way. Then it goes negative. Negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, negative 1. Then it starts coming back up. It bottomed out at negative 1, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and back to 0. And that pattern continues. All right, so I wanted you to see how the numbers go. Now we're going to take just a minute and look at the curves. Okay, now let's start with the sine function. You'll see sine, as we mentioned earlier, sine of 0 is 0. And then at 30 degrees, it is 1/2. At 45 degrees, it's the square root of 2 over 2. At 60 degrees, it's the square root of 3 over 2. And at 90, it is 1. Then it comes down, square root of 3 over 2, square root of 2 over 2, 1/2, and back to 0. And then continues like we just looked. Notice your cosine starts at 1. Square root of 3 over 2, square root of 2 over 2, they are the same here. 1/2, 0, and then it goes negative all the way back up to where it started. So that lets you see how the curve fits in with the numbers and with the graph. The last thing we want to look at is how to recognize our radians and our degrees. Frequently the ACT will reference angles in terms of their radian terminology rather than just degrees. So we're going to label the unit circle in degrees, and then we're going to label it in the radians. So let's take a look at this. First of all, I have it so that we can see this is 0 degrees. I get to 30 degrees, 45, 60, and 90 degrees. Now I continue on. I'm adding 30 to the 90, and that gets me 120, 135, because I've added 45 to the 90. Now I am adding 60 to the 90, and I get 150. Now I'm at 180. I go past 180 for 30 degrees, and that makes this one 210. I go past the 180 for 45, and it makes it 225. I add 60 to it, and it's 240. Down here, I am at 270. Now, I come back up the other side. 270 and 30 is 300. 270 and 45 is 315. 270 and 60 is 330. All the way back to 360. Okay? Now we're going to come back and see what these are in terms of radians. In radians, what we have is 360 degrees is equal to a full circle. Well, in radians, it's 2 pi. So this is 2 pi, and we start at 0 pi. That tells us that 180 degrees has to be equal to pi. That also means that 90 would have to be equal to pi over 2 because it's halfway to 180. And if I add half to it, I'm going to end up with 3 pi over 2 is equal to 270. That's actually 1.5 pi is 270 degrees. Now we're going to break it down into the 45s. Okay, well, half of pi over 2 is pi over 4. Well, pi over 4 here, I'm going to pi over 4 past this one gives me 3 pi over 4 for 135 degrees. 225 then would be 5 pi over 4. It's 1/4 of a pi more than pi. I go over to this one, 315 is going to be 7 pi over 4 because it is 1/4 pi past 1.5 pi. So that gets the 45s. Now what we're going to do is take a look at the 30 degrees. Okay, now if you look at this, 30 goes into 180 6 times. So 30 degrees is actually equal to pi over 6. It is 1/6 of the way to 1 pi. 60 degrees then would be 2 pi over 6. But we shorten that and reduce that fraction and get pi over 3. So 60 degrees is 1/3 of the way. 90 then would be 3/6 of pi, which reduces to 1/2 or pi over 2. 120 degrees is going to be 4 pi over 6, and that reduces to 2/3 pi. We go to 135, and it's going to be, as we've already mentioned, 3 pi over 4. 150 then is 5 pi over 6. Because 30 times 5 is 150, it is 5/6 of the way to a full pi. 210 then would be 1/6 of a pi past the full pi, which makes it 7 pi over 6. 1/6 of a pi past that point. Now we're going back to our thirds. This would be at 180 is 3/3, so now we go to the 240, and it is going to be 4 over 3 pi, 4/3 pi. 300 then is 60 degrees past the 1.5, so instead of being 1 3/6, it's 1 4/6, which is going to make it 5/3 pi. And 330 is going to be 11/6 pi. You don't get into that very often, but 11/6 pi is 1/6 pi short of 2 pi. So this helps you see what the radians are. Now, to think about it this way, radians are just measuring the distance we are traveling around the circumference of the circle. Degrees tell us how much we are rotating about the center of the circle. Totally different things, but they are equal to each other if you remember that pi equals 180 degrees. Okay, I think we've covered our unit circle a lot for you. Let's now take a look at some of the problems using this and see what we can get from that. Number 34. It tells us if we're between 90 degrees and 180. So you just want to remember what that's talking about. We are in the second quadrant because that would be 90 and this is 180. Okay, so if we're in that range, what are we looking at? They said the sine of theta is 5 over 13. So what's the cosine? So you're setting up a 5, 12, 13 triangle. Okay, the sine of theta is equal to 5 over 13. Notice, if you remember your expression, all students take calculus. My sine is positive in the second quadrant, but the cosine is negative. So that tells me these two positive answers would not be there. And this is 12 here because it's 5, 12, 13. A squared plus b squared equals c squared. So if I needed to know what that one was, I would know that it is 169 minus 25 is 144. Square root of 144 is 12. So just to help you realize that 5, 12, 13 really helps us out. Now we're at a cosine of theta. Well, the cosine of that is just going to be the 12 over 13, but it will be negative. A couple of other things to notice. Remember, the maximum value for cosine is positive 1 and sine. The minimum value is negative 1. So you can never have a number smaller than negative 1, which also takes out j and k because they are smaller than negative 1. Number 60. In the figure below, a ladder on level ground rests against the side of a building. The ladder reaches a point on the building that is 20 feet above the ground. The angle formed by the ladder and the ground is 65 degrees. A point on the ladder is 4 feet from the wall. Okay? And then it tells us what is the vertical distance from this point to the ground. So we're going to sort of blow this up a little bit so we can see what we're looking for. First of all, they are wanting us to get x, which is this distance up to here. Well, we know the total distance is 20 feet. We need this distance right here. So if we look at this, the angle 65 degrees is going to be the same here as it is here. And this distance, being a 4, is my adjacent. This is my opposite. So I'm looking for the function that has opposite and adjacent, and that's going to be tangent. So what this distance would actually be is I would be saying tangent of 65 is equal to opposite, which is x, over adjacent, which is 4. Multiply the 4 over here, and I get 4 tan 65 is equal to x. Now that I know my x distance, I know this distance here, I can subtract it from the 20, and that gives me x. So it would be 20 minus the 4 tan 65. Okay, that makes F the answer to number 60. Number 39, what is the value for the tangent of EAD? EAD is this angle here. Well, one of the things to know is that my tangent, since this is a square, that side is parallel to that side. And if I had a triangle here, and this was perpendicular, that was perpendicular, that's perpendicular, all of these are similar triangles, and I can, from a tangent standpoint, the tangent of this angle is going to be exactly the same whether it's looking at this triangle or this triangle. So the EAD is going to be the same as going from OAB. And that means it's going to simply be opposite, which is 5, because I'm looking at my x-axis here, and that distance is 5. And my distance on the y-axis is 3. So it's simply 5 over 3, making D the answer on this one, 39. Number 46. A pond's length, represented by AB, is determined by using the right triangle ABC shown in the figure below. The distance from A to C is 40, and the measure from CBA is 28 degrees. We want to make sure we find that CBA, that's this distance here, is a 28 degree angle. Which of the following expressions represents the length in meters of the pond? Okay, so if this is my 28, across from it is opposite. This distance would be my hypotenuse. So I'm looking for the function that uses opposite and hypotenuse, and that would be sine. So I'll set this up as sine of 28 is equal to 40 over x, which is my hypotenuse that I want. Multiply both sides, and I get x sine 28 equals 40. Now we divide both sides by the sine of 28. So 40 over sine 28 would be my answer, and that makes it F. In the figure below, ABC is a right triangle with three sides of different lengths. What is the value of sine squared A plus sine squared B? Well, let's take a look. To do my sine of A, it's going to be opposite over hypotenuse, but it's squared. So what I'm going to have is A over C squared plus, now the sine of B. So going to the sine of B, I get over here, and opposite over hypotenuse, B over C squared. What would they equal? Well, we can set this up as A squared over C squared plus B squared over C squared, which equals A squared plus B squared over C squared. And at this point, you want to recognize that since it's a right triangle, A squared plus B squared equals C squared, and we just get C squared over C squared equals 1, making F the answer. The angle of elevation from a point on the ground to the top of a building is 37 degrees, as shown below. The point is 75 feet away from the building. Which of the following is closest to the height in feet of the building? And notice they give us the value, so they want us to calculate an actual number. So the first thing we do is go to the angle 37 degrees. Across from it is opposite. This is adjacent. So what did they give us? They gave us the adjacent. What do they want? Opposite. So we know we're using the tangent function. So tangent of 37 is equal to 0.754. So now we would say 0.754 equals x over 75 multiplied by 75 times 70.754 equals 56.5, which is 57. Making G the answer to 38. Now this one's a hard one. Number 54. The expression 4 sine x cosine x is equivalent to which of the following? And then they give us a note. Now I use this problem because I want to really emphasize that when the ACT gives you a note or an equation, you always use the equation that the ACT gives you. Well, the first thing I did when I looked at this the first time is I recognized, well, they got this y in here. Sine of x plus y is equal to sine x cosine y, cosine x sine y. Well, this is the sum angle formula, and usually you would see this if a teacher in a class asks you what is the measure of the sine of 75 degrees, and they're wanting you to do it as the sine of 30 plus 45. And then you can get the sine of the 30, of course, would be the 1/2, and this is going to be the square root of 2 over 2, and you solve the other one, and you can put them together and get a radical answer on the top. And that's a common trig problem for a test and so forth. But that's not what the ACTs want us to do. We look at this and we start wondering, where is the y coming from? I don't know what the y is coming from because they didn't give me a y. They just said they want 4 sine x cosine x. This is what makes the problem hard. In trig or in math in general, sometimes they like to write a formula and they want you to recognize that you need to say let x equal y. So now what we have is the sine of x plus x is equal to the sine x cosine x plus cosine x sine x. Now that's actually the sine of 2x is equal to 2, because these are identical, 2 sine x cosine x. Okay, well, we want 4 sine x cosine x, so now things are starting to look like we can figure it out. We're going to multiply both sides by 2. You multiply both sides by 2, and we get 2 sine 2x equals 4 sine x cosine x, and that makes the answer F, 2 sine 2x. '59, the domain, remember the domain is your x-axis, of the function y equals 3 cosine 5x minus 4 plus 1 is all real numbers. Which of the following is the range? Range is your y-axis, your up and down. Okay? Well, here's the thing. The maximum value for cosine is a plus 1 and a minus 1. So it can go as high as a positive 1 and that's it, or it can go as low as a negative 1. Never greater than a 1 or less than a negative 1. So since we don't know anything about what x is, we're just going to substitute in the maximum and the minimum, and then everything in between works. So I would have 3 cosine of 5x minus 4, parenthesis ends, plus 1. Well, this part, cosine 5x minus 4, I'm going to substitute with a plus 1 because that is as big as it can be. I don't care if x is a million. The biggest the cosine is ever going to be is a 1. So now I just have a 3 times 1 plus 1 equals 4. So now the next one that I would do would be the minus 1. So I would have a 3 times a minus 1 plus 1 is equal to negative 3 plus 1 is equal to negative 2. And that gives me the answer D, from a negative 2 to a positive 4. Lee is standing at point L on the north side of the small canyon shown in the figure below. As measured by a line of sight, Lee is 2 miles from an observation tower at T, and she is 3 miles at a scenic overlook at S. Lee, the observation tower, and the scenic overlook are at the same elevation. The measure of S is 28 degrees. Which of the following equations, when solved, gives the measure of angle T? So what they're doing is giving you the law of sines. The law of sines is for triangles that do not have a right angle. And that's what we have here. We've got a 2, we've got a 3, and we have this 28. Now the way that the law of sines works is we know this angle and we know this length across from it. And what we want is the other one. This when we look at this, we're wanting to know the measure of angle T. We want this angle here. The law of sine says that the ratio of the sine of 28, so we would say the sine of 28 is to 2, the side across from it, as the sine of T is to the 3 that's across from it. The next step would be to cross multiply and solve, but we don't need to because all they wanted was the expression, and that makes the answer A surveyor wants to approximate a river's width. As shown in the figure below, points A and C are located on the west bank of a river, and point B is located on the east bank of the river, such that ACB is a right angle. She measures and finds the length of AC as 54 meters, and the angle of BAC is 68 degrees. Given these approximations in the tables below, in this case they give us the 22 and the 68, which of the following is closest to the river's width as measured, as represented by the length BC? Okay, so we go to the 68 degrees. Across from the 68 degrees is our opposite, and this one is our adjacent, the 54 is. So what did they give us? Adjacent. What do they want? Opposite, tangent. So we're going to say that the tangent of 68 is equal to x over 54. Now, we know that the tangent of 68 is 2.475 is equal to x over 54. So now we just have to multiply 54 by 2.475, and we get 133.65 is equal to x, and that makes the answer C. .45. In triangle ABC, A measures 101, B measures 25. What is the length of BC? Okay, now notice this. They want to know the length of AC. That is going to be my x. This one now covers the law of sines, but you notice they don't show that the sine of A is to A as the sine of B is to B, and so forth like that. They give it to you this way, and I wanted you to see both of them pretty close together. The law of sines states that the lengths of the sides of a triangle are proportional to the sines of the opposite angles. That means exactly the same thing. So what we're going to do is take the sine of 101 is to 165. Sine of 101 is to 165 as the sine of 25 is to x. Sine of 25 is to x. Now we're going to cross multiply, and we get x times sine of 101 is equal to 165 times sine of 25. Now we want the x, so we're going to divide the sine of 101 over here. We'll just take it out on this side. Now we're ready to do the math. They give us the numbers. The sine of the 25 is 0.423. The sine of 101 is 0.982. So when we plug these in, we get 71.07, which makes the answer 71, or D. .56. In the standard xy coordinate plane, what is the range, the y values, of this defined by the equation y equals 3 sine 2x? Remember, the biggest value for sine is going to be a positive 1, and the minimum value is a negative 1. So 3 times 1 gives me a positive 3. 3 times negative 1 gives me a negative 3. So my range is from negative 3 to positive 3, or J. 57. The Leaning Tower of Proville creates an 85-degree angle between itself and level ground around the tower. The tower's shadow is 100 feet long. If it can be determined which of the following expressions gives the distance in feet from the top of the tower to the ground. Well, notice what we've got. If we take this tower and we show that this is an 85-degree angle, and we know that the shadow is 100 feet long, there's something missing. We don't know where the sun is. The sun could be up here giving us a 100-foot shadow. The sun could be way back over here giving us a 100-foot shadow. We have no idea where the sun is because we don't know our angle here. So we cannot solve this one, making E the correct answer. In triangle ABC shown below, the angle measures are marked and the lengths are given in meters. Which of the following is an expression for the length in meters of AB? This is another one of our law of sines. This time you notice they've given it to us again. Sine of alpha is to A, as a sine of beta is to B, sine of gamma is to C. All we got to do is set this one up. And they've asked us for the length of AB. So this is my X. So the first thing I do is I'm going to set up the relationship. Sine of 20 is to 90. Sine of 20 is to 90. As, now I need this angle right here. Well, I've got a 135 plus a 20 is 155. That means this angle has to be 25 degrees. 180 minus 155. So now I would have sine of 25 is to X. And I would be able to cross multiply now and get X times sine 20 is equal to 90 times sine 25. And divide both sides by the sine of 20. You always want to take time to write this out. You can sometimes get a little fast and a little ahead of yourself and think you spot the answer and be wrong. I watch this all the time with students. So I always believe in writing it all the way out so that we get it correct here. All right, and so I look for sine of 90, sine 25 divided by sine 20. B is the answer to 53. (60) Which of the following expressions gives the area in square inches of triangle shown below with the given side lengths in inches? Now this one is one, whenever they want the area of the triangle, we start with our formula. 1/2 base times height. Now we're in luck here, they gave us the base as a 5, so it's going to be a 1/2 of 5 times the height. Now we need the height. Notice that they gave me a 65-degree angle, so I don't exactly have a 30, 60, 90 triangle relationship here. But I look at the answers and I notice, oh, they got sines and cosines and tangents in here. Let me use that to help me. Now, there's one thing that I don't know. I don't know how this splits. I'm sure this is something less than 2.5 here. It's not exactly going to come down in the middle, but it'll come down closer to point H. But I don't know what this distance is. What I do know is my hypotenuse. So I do exactly like we always say. We go to the angle. Across from the angle is opposite. This is my hypotenuse. That means I'm going to be using the sine function. Sine of 65 is equal to x, opposite, over 6. Multiply by the 6, and I get 6 sine 65 equals x. So now I plug it back into my equation. 6 sine 65. So 1/2 of 5 times 6 is 30, so that's going to give me 15 sine 65. And 15 sine 65 makes J the answer. Janelle is loading a truck by using a ramp as shown below. The ramp is 8 feet long, and the end of the ramp that's resting off the truck or on the truck is 2.5 feet above level ground. Which of the following expressions gives us the angle of inclination? And you'll notice here they use the arc term. Okay, there's two things in trig you have to remember. First of all, sine of -1 can also be represented as arc sine. Now, something that makes this is the second thing, is sine to the -1. Well, if I have x to the -1, that equals 1 over x. But sine to the -1 does not mean 1 over sine. That would be the cosecant function. So that's not what they're talking about at all. What they're talking about is this arc sine, which means the angle whose sine is. Okay, so we're looking for which angle would have a sine or a cosine or a tangent that would be, this is the opposite, this is hypotenuse, so we can see that it's going to be a sine function. So I'm looking for the arc sine of an angle that has a 2.5 over 8. If I calculated that and took the arc sine of it, it would give me the angle. And so that makes B the answer to 29. The sides of an acute triangle measure 14, 18, and 20 respectively. Which of the following equations, when solved for theta, gives the measure of the smallest angle of the triangle? So here's what we have to do. First, we're going to look through, and we have the law of sines, and we have the law of cosines. Now, they both help us with triangles that are not right triangles, but they do different things. So let's draw this out first. We have an acute triangle. That means when we draw this, we're going to have a long side that's 20, and we'll let that one be this one. And then we're going to come in here. We're trying to make sure we have an angle that's less than 90 degrees. And so it's kind of hard to draw that without the right tool. But we're going to sort of sketch it in and make it so it comes up like that. Okay, now this one is going to be our theta, and it is across from the 14. We know that this side is going to be the 18, and this would be the 20. Now, one of the things that we notice is we don't have a second angle. To do the law of sines, I have to know two angles and one side. But in the law of cosines, I need to know the lengths of two sides and the angle in between them. So what we would have here, looking at the law of cosines, is my 14 squared would equal my 18 squared plus my 20 squared minus 2 times 18 times 20 times cosine of theta. And that makes J the answer to 58. 59. The table below gives the ordered pairs in the standard xy coordinate plane. If a is not equal to 0, which of the following sine functions goes through all the ordered pairs? Okay, this is one of those you're just going to have to test the values. You'd have a hard time sitting here trying to write up the equation that matches the numbers first. Okay, well, we know that if we plug in a 0 for x right here, we will get y equals 0. So that one works, but it also works here, here, and it works in these first three. So now we're going to go to the next one, a 1. A value of 1 for x. So that's going to make sine of pi a times 1 always equals a. Well, the sine of pi is 0. And so if I have that, that's going to equal a. That's really not going to work for this one. So let me try the next one. I have a out in front times the sine of pi over 2, which is 1 times x. And x is 1, so it's the sine of pi over 2. So that one would equal a. It works there. So let me try the next one. Will it work with the next one? Well, I put in a 2. And I say a times the sine of 2 pi over 2, which is equal to 0. And that one works. So if it works on these first three, then that's going to make B the answer. Now this one's a little hard to follow, so I'm going to go back and work back through it one more time and let you see it. I'm going to just change colors here. The first thing is when I plug in a 0, this is my x value. So I would, if I looked at the first one, it would be y is equal to sine of pi a times 0. Well, 0 is going to make all of this a 0, and I'm going to get y equals sine of 0, which is equal to 0. Well, that works in the first test. So now you try the second one. Y equals sine of pi a times 1, which is going to be the sine of pi times a, and they're telling me that's going to equal a. Well, the maximum value that sine can ever be is 1. It doesn't tell me any limits on a except that it can't be a 0. So if I plugged in a 5, I can't get a 5 as an answer because the sine of 5 pi is not going to be 5. So this one can't be the answer because it fails at that second test. Now, when you look at the second answer, you're putting the a out in front. So that means when this is equal to 0, the whole thing is 0. And that works here, here, here. When x is equal to 1, I'm getting the sine of pi over 2, which is 1. 1 times a does equal a. And then I get to 0 again, and then I get to minus a when I get to 3 pi over 2 for the next one. So the answer is B. Another good one here. 59. If cosine squared x plus cosine x minus 2 equals 0, and we're in the first quadrant, then x has to equal what? Well, now we remember that at 0 degrees, the cosine is equal to 1, and sine is equal to 0. So we're going to look at that, and that's one of those things that this 2 sort of helps you out because you know that if I did cosine squared x equals 1 and cosine x equals 1, that both occurs at 0 degrees. So I would say 1 plus 1 minus 2 does equal 0, and that means that the angle has to be 0 degrees, making A the answer to 59. number 46. In this triangle below, we see that FG is 14. To measure to the nearest tenth of a foot, how many feet long is GH? So that's my X. Then it gives me the law of sines. This is another law of sines problem, and they tell me the formula here. So what we're going to do is have the sine of 45 is to X as, and we've got this other measurement here, the sine of 72 is to 14. So we cross multiply and we get 14 sine 45 is equal to X times sine 72. Now we divide both by sine of 72. And we're ready to plug our numbers in. That's going to equal X. So it's going to be 14 times, and the sine of 45 is 0.707 over the sine of 72, which is 0.951. And when you multiply that out and divide on a calculator, you will get 10.4, making G the answer to 46. Last one. An angle with measure phi is shown at a standard XY coordinate plane below. The angle with measure phi has a positive x-axis on one side and has a portion of the line y equals x on the other side. What is the value of the sine of theta? So here's where we go back to our all students take calculus. Let's start with that. They're wanting the sine. We know that in this third quadrant, sine is negative, cosine is negative, tangent is positive. So that tells me I'm looking for a negative answer. It means these two are not going to be an answer for consideration. It next tells me that the slope of the line, or the equation of the line, is y equal x. Well, if you remember, your y equals mx plus b tells us that if I get y equals x, that means my y-intercept is 0, which we see it goes through the origin, and it tells me that my slope, m, has to equal 1. Well, slope equals 1 at a 45-degree angle. 45-degree angle. So that means this would look like this, and that would be 45 degrees, which means this one is 180 right here and 225 here. So the sine of this, any of the 45s, is going to be the square root of 2 over 2, and the only thing that changes is the positive and negative SIGN. All right, so the sine of 45 would be the square root of 2 over 2 here, and the square root of 2 over 2 if it was over here. In the bottom, it's going to be negative square root of 2 over 2, making G the answer to 58. So I hope that working through these problems and explaining them one by one, letting you see such a wide variety of the way they ask similar problems, has been very helpful to you. So hopefully now you're ready to tackle some of the ACT problems, and let's see if you don't do a lot better on your trig questions when they come up. Okay, that completes my trig videos. By now, you have worked through a lot of different trig problems. You've seen how the ACT does this in many different ways, and hopefully this is beginning to come together and you understand a little better what's expected on the ACT in the area of trigonometry. So now, maybe some of those problems in the 40s to the 60s seem a lot less intimidating. Thanks for watching. I hope you have a lot better understanding of trigonometry.